The universe is vast, ever-expanding, and full of mysteries that challenge everything we think we know. In 1929, scientists discovered that the very elements in our bodies originated in the cores of stars. By 1957, we began to understand that the night sky is not just beautiful. It reflects the immense power and complexity of the cosmos. Yet, much of it remains a mystery. We continue to wonder why we exist, why planets and stars take the forms they do, and what other destinies might have been possible. Often, cosmic events unfold beyond our notice until they become impossible to ignore. One such event is happening now with Betelgeuse, one of the largest and most studied stars in our sky. Betelgeuse, a red supergiant located more than 640 light-years away, is so massive that our Sun appears tiny in comparison. Its diameter is estimated to be nearly 1,400 times larger than the Sun, meaning that if it replaced our Sun at the center of the solar system, it would extend past the orbit of Mars. Yet, despite its enormous size, Betelgeuse is relatively cool for a star, with a surface temperature of around 3,500 Kelvin, giving it its iconic reddish glow. Its enormous mass and unstable nature make it a star unlike any other in our night sky, and it is currently showing signs of behavior that has left astronomers both fascinated and concerned. Betelgeuse has been labeled a pulsating variable star, meaning its brightness changes over time. Its luminosity fluctuates dramatically, from magnitude 0 to magnitude 5, across cycles ranging from 185 days to over 2,300 days, reflecting the star's internal pulsations. In February 2021, Betelgeuse's brightness dropped sharply to a V-band magnitude of 1.614, one of the lowest readings ever recorded in modern times. This unusual dimming sparked global attention and speculation, earning headlines around the world and earning the nickname, the Great Dimming. But what causes these pulsations and dimming events? At the heart of Betelgeuse, hydrogen fusion is gradually slowing as the star exhausts its nuclear fuel. Hydrogen atoms fuse into helium, producing energy that counteracts the inward pull of gravity. As hydrogen fusion diminishes, the star's outer layers expand dramatically. Around the core, helium fusion begins, forming heavier elements like carbon and oxygen in a process called helium shell burning. Unlike hydrogen fusion, this process is irregular, producing bursts of energy that destabilize the star's structure, causing its outer layers to expand and contract unpredictably. These pulsations are far from benign. They generate stellar winds strong enough to eject massive amounts of material into space, shaping Betelgeuse's evolution and influencing its surrounding environment. Observed from Earth, the star's fluctuating brightness is akin to the beating of a colossal heart, a rhythm dictated by the intricate interplay between gravity, radiation pressure, and nuclear fusion. Astronomers study Betelgeuse using photometry and spectroscopy. Photometry measures brightness over time, revealing the star's pulsation cycles. Spectroscopy analyzes the light at different wavelengths, unveiling key details about the star's temperature, chemical composition, and motion. By combining these methods, scientists can build a comprehensive picture of Betelgeuse's behavior. Within the star, stellar convection drives the movement of energy. Hot plasma rises from the core while cooler matter sinks, transporting energy to the surface. These convection currents create fluctuations in luminosity, contributing to the pulsating pattern we observe. As the star expands, the surface cools and dims. During contraction, the surface heats up and brightens. This constant push and pull is a result of complex interactions between gravity and radiation pressure, a delicate balance that creates the star's rhythmic heartbeat. But Betelgeuse is not just pulsating, it is aging rapidly. Red supergiants like Betelgeuse are in the final stages of stellar evolution, having burned through much of their hydrogen fuel. As the core becomes dominated by helium, heavier elements begin to form, and the star's outer layers swell. These processes lead to irregular pulsations, massive stellar winds, and sporadic dimming events that can confuse even the most experienced astronomers. In addition to its pulsations, Betelgeuse has displayed mysterious surface features. Observations using interferometry have revealed massive convective cells on its surface, some covering areas larger than the orbit of Jupiter. These cells rise and fall over months or years, causing uneven heating and contributing to the dramatic variations in brightness. Dust ejected by these convective outflows can also obscure parts of the star, creating temporary dimming events, which some astronomers suggest may have contributed to the Great Dimming. Betelgeuse's story is also a tale of observation history. This star has been studied for centuries, appearing in the writings of ancient astronomers and mythologies across cultures. Its name originates from Arabic, often interpreted as the giant's arm, or the hand of Orion, reflecting its prominent position in the constellation Orion. Modern astronomers, equipped with powerful telescopes and sophisticated computer models, have turned Betelgeuse into a laboratory for understanding the final stages of massive stars. As Betelgeuse nears the end of its life cycle, scientists anticipate a spectacular conclusion, a supernova explosion. When the star finally exhausts its nuclear fuel, it will collapse under its own gravity and erupt in a brilliant supernova, potentially visible from Earth even during the day. Until that moment, its pulsations, surface activity, and dimming events continue to provide insights into the physics of massive stars, mass loss, and the life cycle of the universe's giants. Studying Betelgeuse is like observing a living, breathing entity. Each pulse, each convective outburst, and each variation in brightness is a direct reflection of the dynamic processes occurring deep within its core. It is a cosmic reminder that even the largest and most stable appearing stars are subject to the relentless forces of physics, energy, and time. Betelgeuse also serves as a cautionary tale for humanity's understanding of the cosmos. It is a reminder that the universe operates on scales, energies, and timelines that are often beyond our intuition. Its eventual supernova will not only illuminate our sky but also enrich the interstellar medium with heavy elements that could one day form new stars, planets, and perhaps even life elsewhere in the galaxy. So, what will Betelgeuse do next? Will the next dimming be another convective outburst, or could it be a prelude to the long-anticipated supernova? Scientists continue to monitor it daily, using cutting-edge observatories, space telescopes, and computer models, eager to capture every flicker, every pulse, and every secret it holds. Betelgeuse is a star on the edge of transformation, a cosmic giant offering humanity a glimpse into the life and death of stars. Its behavior reminds us of the delicate balance that governs the universe and the awe-inspiring forces that shape everything we see in the night sky. Let me know what you think in the comments below. If you enjoyed this cosmic journey, like, subscribe, and turn on notifications, because the story of Betelgeuse is far from over, and when it finally erupts, the universe itself will be watching.